basic idea of completing the square method. So we are looking into the procedure and also why does it, how is it useful and how is it used. So to begin with, we are looking at an example. So the example is we have x square plus 4x minus 5 is equal to 0. Okay, before we get into completing the square method, so this particular equation can be rewritten as this. So if I give you this, can you guys find the roots? You can pause and think it out. Okay, so the procedure is like this. If you have this particular equation, it's simple. Now, all you have to do is add plus 9 both the sides. So we have x plus 2 the whole square is equal to 9. Now, we'll take the square root. So when I take the square root, you have to be aware that this is nothing but plus or minus of 9. So why is that? I'll explain. So square and square root will get cancelled on the left hand side. So we have x plus 2 is equal to plus or minus 3. Okay. Why is this plus or minus 3? We'll make a note of that. See, what does square root of a number mean? So it means that what number should we multiply to get 9? Should we multiply 2 times to get 9? That's what square root means, right? So basically, can I think of 9 as 3 into 3? Right, this gives me 9. And also, can I think of it as minus 3 into minus 3? This also gives me 9, is it not? Right? So end of it, I can write root of 9 as plus 3, if not minus 3, which can also be represented as plus or minus 3. Make sense? So we have alpha, which is equal to x plus 2 being equal to plus 3. So you subtract 2 both the sides and you get 1. Beta, which is equal to x plus 2 being equal to minus 3. Subtract minus 2 both the sides and you'll get x is equal to minus 5. Right? If you transpose and do the math, you'll get this. So we got our zeros. See, this was a quite simple method. I mean, this part was extra. If not, the procedure is quite simple. Few steps only, right? So everywhere it's the same. But the question is, how did we end up with this? How will I get this? So conversion from this point to this point is your completing the square method. Okay. So from this equation to this equation is what completing the square method is about. So now we look into how do we do this. So this is your expression to begin with, equation to begin with. I'll consider only this expression, right? The linear term and the quadratic term. So let me consider that. Consider x squared plus 4x, right? So the basic idea here is to convert any given equation or expression, sorry, in the form of either a plus b the whole square, if not a minus b the whole square. So what is a plus b the whole square? Is a square plus 2ab plus b square. Okay, so I want to convert from this to this, right? So now to convert that, we have a square plus this will be my 2ab. So let me write that 1x the whole square plus I can write 1x the whole square, not an issue. So 4x I'll write it as 2, which I want over here, a which is 1x into what is left out, 2 into 1 into 2 will give me 4. So this looks like my b. So this has to be my b. No other way. Nothing else. So this particular term has to be my b. Right? So now I don't have b square. How will I get b square? Well, let me not confuse you guys over there. I can add 0. So what is the point of adding 0? I mean, are we going anywhere from this? Well, 0, how can I add 0? 0 is a multiplicative identity. So we can add 0 to anything because that won't change the given expression or the equation. So can I write 0 as something like 5 minus 5 or say 4 minus 4, right? Or say 10 minus 10. I can write it as anything, is it not? So the above expression, right, will convert to 1x the whole square is 2 into 1x into 2 plus 2 square minus 2 square, right? I can write 0 as anything. Now look at this carefully. I have my a square, I have my 2a, and this happens to be my b plus b square. This is there. We will not neglect that, but this is what we wanted. And this can be written as a plus b the whole square. So basically, this entire expression, okay, so not a good line. This entire expression can be rewritten as 1x plus 2 the whole square minus 4. Okay, this entire thing is x plus 2 the whole square and minus 2 square is minus 4. This we can substitute back into equation 1. Sub above expression into 1. So we have 1x plus 2 the whole square minus 4, right? In place of this, we are writing this minus 5 is equal to 0. 1x plus 2 the whole square minus 9 is equal to 0. And this is what we have it over here. And this was the entire idea, right? So this is your basic idea of completing the square. So if you want to pause over here, please do so.